we have seen there were 118 elements as of now, including natural artificial elements, and every element different physical and chemical properties, and that needed to be classified in a proper or systematic manner. So scientists from the different parts of the world try to classify all these elements in periodic table. Out of that, we have seen some notable scientists like Brott, Newland, then Octaves, Mendeleev. Mostly these were the scientists. Notable work is done, and the conceptual work is done by Mendeleev and Moseley. So we have seen Mendeleev's law and Moseley's law for the classification of all these elements. Going bit ahead, we have seen what is the modern periodic table. Kya hai modern periodic table? How many vertical columns, that is groups, and how many horizontal rows, periods are there? And then we have seen that is modern periodic table, the classification of element in this periodic table on the basis of electronic configuration. How? The electronic configuration in modern periodic table, or many concepts in the modern periodic table, are related with each other. That is also what we have seen here in this chapter. So we have seen the electronic configuration and group. How group is decided by electronic configuration, or how on the basis of electronic configuration we decide the group, we determine the group. Also, we have seen horizontal rows called as periods. How on the basis of this electronic configuration we have the periods, and how many elements are present in particular period, because we know very well there are 7 horizontal rows known as periods, that is first, second, third, fourth, fifth, sixth, and seventh. So first consists of only 2 elements, second and third consist of 8 elements each, fourth and fifth consist of 18 elements each, sixth consists of 32 elements, and seventh is still incomplete. Why this particular number of elements is present in that particular period, that is also decided by electronic configuration. So we have seen that in detail again. Going bit ahead, also we have seen that is electronic configuration and the classification of element on the basis of S, P, D, and F block elements. So modern periodic table has 4 blocks, that is S block elements, P block elements, D block elements, and F block elements. And this classification on the basis of block is done on the basis of the electronic configuration. As we know very well, the subshell image, the last added electron present or exist, is nothing but that particular block. So all S block element has their last electron in S block. All P block element has their last electron in P block. Same for the D and F block elements, and that's why they have some common properties. Also, we have seen the properties of this S block elements, common properties of P block elements, common properties of D block elements, and common properties of F block element. That is also what we have seen. So with this, almost 70% chapter is over, still there, because with that part what we have seen. One more important part, what is related or what is remaining is nothing but you can see here, that is trends in periodic properties. So as of now, we have to discuss the trends in periodic properties of all these elements. So let's move to the next topic, that is trends in periodic properties. So periodic trends in physical properties. Periodic trends in physical properties. So this is the next main head what we have discussed under here in this chapter. Okay, so up here, when we talk about the periodic trends or trends in physical properties of the elements, that's very important. It's a very conceptual part. जैसे मैंने बताया कि ये फंडामेंटल चैप्टर है, and this chapter is important in order to study the inorganic chemistry. सारा inorganic chemistry study करने में ये periodic table chapter बहुत important है. और periodic table chapter का ये वाला part जो अभी हम देखने वाले हैं, that is how physical properties are trending, how the trends occurs in the physical properties of the elements in periodic table. That is what we have to discuss under this head. That is, you can say, trends in physical properties for these elements. That is what we have to discuss here. Okay. Now there are 2-3 important concepts which need to be fundamentally covered before proceeding to, that is, you can say, periodic trends, because most of the periodic trends depend upon these fundamental concepts. Okay, so number 1 is nothing but effective nuclear charge. Number 2 is nothing but shielding effect, and that is also called as screening effect and atomic size. So first is, you can say, effective atomic number. Number 2 is screening effect or shielding effect. Shielding effect, also called screening effect. And बाकी size. So these two are very important topics. That is what we are fundamentals what we need. See, trends in periodic properties. एक बार थोड़ा सा rough diagram देखते हैं हम लोग. So this is periodic table. Okay, this is periodic table. Sorry, see, yeah. Okay, this is periodic table. Now, this is the top of periodic table. This is, you can say, left side. This is, you can say, right side. Right side. And this is, you can say, bottom. Bottom. इस तरीके से बोल सकते हैं. तो periodic table में हम लोग ये words commonly use करने वाले. This is the top part. This is the right part. This is the left part. This is bottom. Because trends in physical property changes as we move from left to right or as we move from top to bottom. जिस तरीके से अभी इसके अंदर ये रोज नहीं आते, मतलब ये जो दो रखे यहाँ पे वो रोज ट्रेंड्स के अंदर नहीं आते बिकॉज ये यहाँ पे है. बट चलो हम लोग यहाँ पे मानते हैं कि वो उसके अंदर होते हैं, मतलब डायग्राम के अंदर होते हैं. आप इस डायग्राम से हटा भी देते हो इस दोनों को तो भी कोई प्रॉब्लम नहीं है. ओके, सो दिस व्हाट वी कैन सी हियर बॉटम के अंदर. सो नाउ दिस इज द बॉटम पार्ट. ओके, दिस इज द बॉटम पार्ट, राइट, टॉप एंड लेफ्ट. सो all the physical property trends changes top to bottom or left to right बदलने वाले. और इसलिए it's necessary for us to know this, what is the top, what is the left, what is the right, and what is the bottom. This is that before entering into trends in physical property, these two concepts has to be very clear, very clear. Number one is effective atomic number. Number two is the shielding effect. Let's see. Effective atomic number is nothing but the atomic number which we know very well. That is mostly when he was performing the experiment. When he was performing the experiment of, you can say, he was studying the X-rays, and he found that the frequency of emitted X-rays is directly proportional to specific integer, and that specific integer is nothing but, you can say here, this atomic number. So atomic number concept is given by this one. Simply आज की तारीख में हम ऐसा define करते हैं कि atomic number is nothing but the total number of protons present in the nucleus of an atom. That is called as atomic number. Now, हम ये भी अच्छी तरह जानते हैं कि this is nothing but atomic number, but atomic number is always equal to total number of protons present in the nucleus as well as that is equal to total number of electrons present in the outermost orbit. So atom में whatever the atomic number, same is the number of protons and same is the number of electrons, you can say. That's why atom has hole is neutral, because total positive charge which is present on nucleus because of protons is balanced with total negative charge because of electrons. So that got balanced. That is the balance, and hence that we call it as, you can say, atomic number. And that is the effective atomic number what we have discussed here. That is the effective atomic number, that also called as effective nuclear charge. The reason behind that, electron may decrease or increase, proton remain the same, and that's why the atomic number remain the same. So total nuclear charge on the nucleus remain the same. So the total protons present in the nucleus, that matters a lot. That determines the total positive charge present on the nucleus, and that is nothing but the effective atomic number we can see here, or effective atomic charge what we can see here. So effective atomic number is nothing but the atomic number, and the total charge present on the nucleus is nothing but the effective nuclear charge. Also, you can say it. So generally, होता क्या है कि you can say atomic number is equal to proton number, and which is equal to, you can say, electron number. ये होता है. But sometimes it happens that this electron may decrease or increase, but this proton remains the same, and that's why atomic number is nothing but the proton number. Protons are positively charged and electrons are, you can say, negatively charged. So normally in atom this positive and negative charge is balanced, but sometimes because of loss of electron, maybe due to gain of electron, this electron number may increase when the reaction occurs or when the cation anion is seen, but this proton number remains the same. So the proton number shows the total positive charge present on the nucleus, and that is also called the nuclear charge. So ये nuclear charge आता है, and that is called the effective nuclear charge or effective positive charge present on the nucleus that comes to it. वो एक important चीज है. दूसरी important चीज है that is shielding effect, also called the screening effect. अभी screening effect क्या होता है इसमें? Structure of atom हम जितना जानते हैं कि this is the nucleus, whereas these are the cells, subcells, and orbital in which electrons are present. तो सी इलेक्ट्रॉन्स, पहले इसमें 2 इलेक्ट्रॉन्स होते हैं, फिर इसमें 8 इलेक्ट्रॉन्स होते हैं, आप अच्छी तरह जानते हो, फिर ये नंबर बढ़ता जाता है. So these are the electrons. shielding effect क्या होता है? ये फिर screening effect क्या होता है? So this is the nucleus which is surrounded by the crowd of electrons and it is a spherical one. Though I have drawn the diagram on the board, which is a 2D diagram. ये 2D diagram है, समझिएगा आप लोग. But actually में this is the spherical structure. The structure of atom is a spherical one. So this nucleus is surrounded by the electrons. Nucleus is surrounded by the electrons. More the atomic number, more electrons are there, and more the electrons, number of shells are there, and that's why this nucleus is surrounded by electrons, is surrounded by shells, subshells, and orbitals. So more the electrons, so this atom appears to be crowded, and that is surrounded by electrons. So if suppose there is some particle which is outside this one, it has to approach the nucleus, then it has to go through this, it has to penetrate this electrons over here. Whatever the electrons here outside, that electron has to be penetrated. So in order to reach to this nucleus, we have to overcome this the different types of forces which are present because of these electrons. So simply this structure of atom appears that this protons or nucleus is surrounded by the crowd of electron, by the shell, substance, and orbital. So that is a bit like a shield one. जसे की shield म्हणजे मराठी मध्ये सांगायचं झालं तर ढाल म्हणतात, फाईट करत असताना युद्धामध्ये वगैरे ढाल वापरली जायची, त्याला आपण shield असं म्हणतो. As like that, this is the nucleus which is protected by this shield of electrons, because electron covers that nucleus within this one, and that's why this structure bit appears like shielded by the crowd of electrons. That nucleus is shielded by the crowd of electrons, and this is called a shielding effect. And that's why suppose, or it's naturally occurs that this nucleus which is positively charged has the attractive power towards these electrons, because electrons are negatively charged. There lies a electrostatic force of attraction. This nucleus being a positively charged and electrons being negatively charged, there lies an attraction between all the electrons and nucleus. So all electrons are bind together with nucleus due to electrostatic force of attraction between positive and negative. So all electrons are held with this nucleus due to electrostatic force of attraction. No doubt. Now the thing is that this nucleus has to attract all the electrons. This nucleus has to attract all the electrons, and it apply attractive force over all the electrons. But see, this electron is far away from the nucleus. In between, there are many cells and subcells. So if the number of cells increases, number of subcells increases, then the farthest electron has a less attractive force by this nucleus. It has very less force of attraction by this nucleus. Nucleus has to help this last electron, and this attractive force comes through this different shells, subcells, and orbitals. And that's why if the size increases, then this nucleus it becomes nucleus difficult for the nucleus to attract the last electrons. So comparatively, the attractive force between the nearest electrons and this farthest electron will be different, because the farthest electron to attract will be more difficult because it's far away, whereas because this nucleus is shielded between the crowd of these electrons, so this last electron won't get that attractive force because this nucleus is shielded, isn't it? So this is the shield concept, like that what we get here. So in order to bind the last electron, in order to bind the outermost electrons, the attractive force has to overcome through this all the inner shell, subcells, or orbitals or electrons, and then it can attract the last electron. That happens. Clear with this? Now the thing is that these two forces or these two things may impact over this trends in physical properties. So number one is, you can say, effective nuclear charge or effective atomic number and the shielding effect. So atomic number gives the proton number, and that nothing but the total nuclear charge or effective nuclear charge. And the shielding effect is this how much electron crowd is around the nucleus, that decide the shielding effect. And because of this shielding effect, if the nucleus is crowded in more and more electrons, that called as the shielding effect, that will affect many of the properties and many of the physical properties and the trends. So that is what we are discussing over here. So as the nuclear charge increases, as the cell subcells increases, the shielding effect also increases. क्योंकि हम जानते हैं periodic table में this these are the groups, vertical columns are the group. While coming down the groups, हम जानते हैं कि here number of shells increases. मतलब फर्स्ट एलिमेंट है हाइड्रोजन का फर्स्ट सेल है, तो उसके नीचे लिथियम में 2 सेल्स है, सोडियम में 3 सेल्स है, पोटेशियम में 4 सेल्स है, रुबिडियम में 5 सेल्स है. So on cells increases. So as we come down, yes, Prashant, no doubt. Prashant has posted interactive post. Yes, as we come down these groups, shells increases, or if shells increases, then shielding increases. No doubt at all, because more and more electrons are there which surrounds the nucleus, and that's why as the shells increases, substance increases. Shells increases means substance orbital increases. That's why the shielding occurs more. While moving to this one, from left to right, हम जानते हैं, हमने देखा है, मैंने बताया था आपको कि सोडियम का याद रखना है आपको. यहाँ पे देखिए, this is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. सोडियम के बाद मैग्नीशियम, एल्यूमिनियम, सिलिकॉन, फास्फोरस, सल्फर, क्लोरीन, then here argon. ये हमने देखा है. So this is from left to right along the pyramid, and this is along the group, top to bottom. So when we move top to bottom, shells are added, and when we move left to right, shells remain the same, because हम जानते हैं electronic configuration of sodium shows it has a third shell 3s1, and if we see the argon, it has 3s2, 3s2, 3p6, but it has again third shell. So shell remains the same across this period. तो पीरियड में शेल्स चेंज नहीं होता है, ग्रुप में शेल चेंज होता है. तो पीरियड में शेल चेंज नहीं होगा तो शील्डिंग इफेक्ट ज्यादा बदलेगा नहीं, बट इसमें बदल सकता है ना. Yes, no doubt question. So we'll see the impact how it happens over here, but these are the two very fundamental concepts which are needed to discuss the trends in physical properties: effective nuclear charge or atomic number, and shielding effect. So what is atomic charge or nuclear charge? I stated, or I cleared this, and what is shielding effect? That is also what is a screening effect. Shielding effect is also what is a screening effect. That is also what we have seen. With this now, let's proceed to the topic. That's what is physical trends. Actually, physical trends. What we have to discuss here. Okay. So let's go to the physical trends. So this is the top. Now, first is nothing but the atomic size trend. So again, we have to discuss the atomic size trend, top to bottom, left to right, no doubt at all, because there are some trends and there are some uncertainties. That's what we will discuss here. So सबसे पहले देखते हैं कि atomic size. See, size of the atom matters when we discuss the physical and chemical properties. There are many things depends upon the atomic size over here. So we have to discuss how the trend for the atomic size changes here in this periodic table. Simply देखिए, मैंने बताया कि this is the vertical column, that is first group. ये learn कीजिएगा, and then एक third वाला जो period की बात कर रहे हैं हम लोग, वो भी थोड़ा, ये सारे elements easy है, common है, वो एक बार याद रखिएगा. जो बार-बार आएंगे तो फिर थोड़ा पूरा periodic group का उससे थोड़ा सा idea आ जाता है. So atomic size की बात करते हैं. सही देखिए, top to bottom atomic size कैसे define करेंगे हम लोग? Size will be defined by radius of the atom, right from the nucleus to the outermost electron. So radius of an atom defines or determines the size of an atom, and radius is nothing but the radius of this atom is decided by right from the center nucleus to the outermost electron, outermost shell. अभी एटम के अराउंड में कितने शेल्स होते हैं, ऐसा अगर कोई सवाल आता है तो इनफिनाइट शेल्स होते हैं. किसी भी एटम के अराउंड में इनफिनाइट शेल्स होते हैं. बट जब हम एक्चुअली इलेक्ट्रॉनिक कॉन्फिगरेशन देखते हैं, से फॉर एग्जांपल सोडियम की बात करते हैं, मैं यहाँ पे लिखता हूँ कि सोडियम whose atomic number is 11, 1s2, 2s2, 2p6, 3s1. This is the electronic configuration of sodium. This is the electronic configuration of sodium. अब देखिएगा, सोडियम का outermost shell थर्ड है, so first, second and third. This is the outermost shell. तो सोडियम में ये वाला सेल है नहीं है, ये वाला सेल, या फिर अगर वो सेल है तो कंसीडर नहीं किया जाता, because there are though infinite shells around this atom and all. It is considered only up to the last electron. The shell in which the last electron is present, that only is considered. That is the only size of an atom. So suppose it's the sodium. The sodium has only 3 cells like this one. So these are the 3 cells. You can say 3 cells. This is first, second, and third. And this is the electron. This is the electron. This is the electron. So the radius of the last electron from the nucleus decides the size of an atom. The size of an atom decided by the radius of the last electron in which shell does that exist. That matters a lot. So in which cell is that exist, that matters a lot. So this is the size of, you can say, sodium atom. So the last electron occurs in third cell, and the radius of the third cell, it may be cell, it may be subcell, it may be orbital, whatever that. That radius will be determined, counted, and that will decide the size of an atom. So that is what we can say about the sodium. अभी हम लोग टॉप टू बॉटम की अगर बात करते हैं तो सी हाइड्रोजन हैज ओनली वन सेल. एटॉमिक इलेक्ट्रॉनिक कॉन्फिगरेशन ऑफ हाइड्रोजन shows 1s1, लिथियम shows 1s2, है ना, 1s2 and 2s1. This is the electronic configuration. So simply you can say hydrogen has only one shell. Lithium has 2 cells like this one. whereas sodium has 3 cells, potassium has 4 cells. तो आप अंदाजा लगा सकते हैं कि this is the hydrogen, this is lithium, this is sodium, so on, potassium 4, 5, 6. As we come down the group, cells increases. अभी cells increases means radius increases, or radius increases means size of atom also increases. This is the trend. When we talk about the trends in physical properties, the atomic size itself is one of the important property. This atomic size increases down the group. Hydrogen, lithium, sodium, potassium. As we comes down the group, atomic size increases. Why the atomic size increases? Because the shells increases. 100% one phenomenon is another. That there is another phenomenon called effective nuclear charge that also increases, because हम जानते हैं कि hydrogen has the charge atomic number 1, so that's why it has +1 charge. It has +3 charge. It has +11 charge. So the charge increases, no doubt. Nuclear charge increase होता जाता है. But though the nuclear charge increases, this means it should contract the atomic size. Atomic size को क्या करना चाहिए? Contract चाहिए. See, न्यूक्लियर चार्ज, हाइड्रोजन का पॉजिटिव चार्ज मतलब न्यूक्लियर पॉजिटिव चार्ज +1 है, सो +1 न्यूक्लियर चार्ज कितना अट्रैक्ट करेगा? व्हाटएवर दैट, अकॉर्डिंगली हियर +3 है. अब ये +3 है मतलब ये न्यूक्लियर चार्ज ज्यादा है. दिस इज +3, इट विल अट्रैक्ट मोर. +3 विल अट्रैक्ट मोर, ये थोड़ा ज्यादा अट्रैक्ट करेगा. यहाँ पे +11, ये और ज्यादा अट्रैक्ट करेगा. न्यूक्लियर चार्ज इंक्रीजेस, सो attraction towards the electron also increases. So attraction बढ़ता जाता है, no doubt. So in that sense, as we come down, hydrogen, lithium, sodium, potassium, nuclear charge also increases. So down the group, nuclear charge also increases, but shells also increases. So nuclear charge तो बढ़ता जा रहा है, shell बढ़ता जा रहा है. तो shell अगर बढ़ता जाएगा तो उसे contract करना उतना easier बात नहीं. So here nuclear charge remains effectless, being the shell is continuously added. Shell continuously add होते जाता है. That's why the only thing is that if shell is added, size has to increase. Though the nuclear charge increases, you won't be able to contract the size of an atom. It won't be able to contract the size of an atom. So that happens here in, you can say, down the group. Let's move across the period. When along the period, across the period, हम लोग जब move करते हैं, left to right जब move करते हैं, see sodium, magnesium, aluminium, silicon, chlorine, argon. तो सोडियम का ये है, आर्गन के दिखते हैं. सोडियम पे मैग्नीशियम, आर्गन का 18 आता है, आर्गन 18. So क्या होगा? 1s2, 2s2, 2p6 and 3s2, 3p6. So this is the electronic configuration of argon 18. So sodium has nuclear charge +11, argon has nuclear charge +18. Sodium has outermost shell, third shell, and this has outermost shell again, third shell. तो अब देखिए, आर्गन की भी बात करते हैं. ये अभी सोडियम का एटम है. आर्गन का भी क्या होगा? ये आर्गन का एटम है, जिसके अंदर वापस यहाँ पर आपको 3 शेल्स दिखाई देते हैं. दिस इज सोडियम एंड दिस इज आर्गन. तो अब देखिए, when across the period हम बात करते हैं, sodium and argon both are the element which have the same shell. Sodium has 3 shell, third shell, and argon is also third shell. Now the thing is that nuclear charge increases. दोनों का outermost shell 30 है, दोनों का outermost shell 30 है. Nuclear charge sodium का +11 है और इसका nuclear charge +18 है. So absolutely this nuclear charge is larger, so it will attract more. अभी ये +11 को थर्ड शेल ही अट्रैक्ट करना है और ये +18 को भी थर्ड शेल ही अट्रैक्ट करना है. So what happens now here? Being this nuclear charge is higher, this will attract this charge more. This attract this shell more, and that's why the size goes on decreasing. One thing is very clear here. Instead of argon, make it chlorine 17. Make it chlorine 17, 3p5. The reason behind that, the one important point behind this is that the noble gases do not comes under any of the trend. Noble gases, तो यहाँ पे रखे हुए हैं. So this is a very important or special, that is, you can say noble gases. Inert elements are not considered in any of the trend because their octet is completed, and that's why they are not considered in any of the trend. So trend is considered up to halogen only, chlorine तक आएगा. So जैसे हम लोग सोडियम से क्लोरीन की तरफ मूव करेंगे, तो देखिए ना, सोडियम का एटॉमिक नंबर +11 है, मैग्नीशियम का +12 होगा, एल्यूमिनियम का +13 होगा, सो ऑनवर्ड्स वो बढ़ता जाएगा. क्लोरीन तक वो +17 जाता है. क्लोरीन तक कितना होता है? +17 जाता है, +17. सो शेल रिमेन द सेम अक्रॉस द पीरियड. शेल्स किसी भी पीरियड में आप जाइए, किसी भी पीरियड में जाइए, शेल रिमेन्स द सेम, बट द न्यूक्लियर चार्ज इंक्रीजेस. तो इंक्रीज न्यूक्लियर चार्ज कॉन्ट्रैक्ट्स द साइज. तो हम सोडियम की और क्लोरीन की कंपैरिजन करते हैं, सोडियम की और क्लोरीन कंपैरिजन करते हैं, तो सोडियम हैज अ स्मॉलर लार्जर साइज एंड क्लोरीन हैज अ स्मॉलर साइज because atomic size contracts across the period. Reason क्या है? Shell remain the same, but atomic number increases. So increase the atomic number increases the effective nuclear charge, and effective nuclear charge attracts the outermost shell, third shell, and that's why size got contracted. Plus 11 को भी third cell attract करना है और plus 17 को भी third cell ही attract करना है. So that's why no doubt at all this is a more charge, this is a higher charge, and this higher charge attracts the shell more, and that's why size contract होता है. So sodium और chlorine को हम compare करते हैं तो sodium is larger in size whereas chlorine is smaller in size, and this trend is not for only this third period. This for all the periods across this total this throughout this periodic table. If we move from left to right across the period, any of the period, you can take first period, you can take second, whatever the period you can take. All the periods, size, atomic size decreases from left to right. Left to right atomic size क्या होता है? Decrease होता है. Top to bottom atomic size क्या होता है? Increase होता है. उसका reason बताया मैंने कि top to bottom atomic size क्यों increase होता है, उसके पीछे reason बताया मैंने. Because shells increase होते हैं, nuclear charge भी increase होता है, shells भी increase होते हैं. और जो increased nuclear charge है, it won't affect the increased shell number. Shells बहुत ही ज्यादा मात्रा में बढ़ रहे हैं और increased shells को attract नहीं कर पाएगा. This is the trend regarding the atomic size. Yes, there are some certain irregularities. Here are trend. हम trend की बात करते हैं तो here are trend की left to right. General trend की अगर बात करनी है तो left to right atomic size decreases. Noble gases, inert gases are never considered in a trend. So that trend has to be considered up to the 17th period. Left to right atomic size decreases and top to bottom atomic size increases. What are the reasons behind that? Already stated. Two major reasons. Number one, atomic nuclear charge increases, but at the same time shells also increases. Or across the period की बात करते हैं तो shell remains the same, लेकिन nuclear charge increases, and that's why the size contracts. This is the general trend. Left to right atomic size decreases and top to bottom atomic size increases. Left to right atomic size decreases, but there are some certain irregularities. हम लोग phosphorus की बात करते हैं और हम लोग सल्फर की बात करते हैं तो साइज में डिफरेंस आएगा. सिलिकॉन और phosphorus की बात करते हैं तो साइज में डिफरेंस आएगा. जनरल ट्रेंड है यहाँ पे साइज बढ़ना चाहिए. जनरल ट्रेंड है कि साइज बढ़ना चाहिए. लेकिन there are some other factors which affect the atomic size. That is nothing but the full filled atomic orbital, half filled atomic orbital, partially filled atomic orbital. These are the concepts which affect affect this trend. So 100% there are some certain irregularities in atomic size to again. तो उसमें अंदर 100% irregularities थोड़े से मिलते हैं, लेकिन जनरल ट्रेंड नहीं बदलता. जैसे कुछ एक्सेप्शन जरूर होते हैं. There are many concepts or many things what we talks or tells. कई सारे कॉन्सेप्ट के बारे में हम बात करते हैं, लेकिन जरूर वहां पे कुछ ना कुछ अपवाद होते हैं, कुछ ना कुछ एक्सेप्शंस होते हैं. तो उसी तरीके से यहाँ पे there are some certain irregularities. कुछ irregularities जरूर इसके अंदर मिलता है और वो यहाँ पे जरूर उसी तरीके से है. No doubt. Clear with this? So that is you can say the trend regarding the atomic size. Atomic size के बारे में आपको ट्रेंड इसके अंदर मिलता है. Let's move to next. तो atomic trend क्या है? Left to right decreases, top to bottom increases. The reasons are effective nuclear charge and screening effect, shielding effect. Top to bottom क्या होता है? Shells बढ़ते हैं तो shielding बनता है, मतलब screening effect बढ़ता है, shielding बढ़ता है. So nucleus is not able to attract the outermost electron more, and that's why size expands. Size थोड़ा सा expand होता है. So that is the shielding effect which is responsible for that one. और left to right जब move करते हैं तो shielding effect is not that much because shell is not added. So shielding effect is less, and that's why size contract होता है. So these are the reasons behind this atomic size. Okay. Let's move to next. That is nothing but the atomic radius. Even I stated it with some irregularities. Atomic radius. Atomic radius. So let's move ahead with the atomic radius. Or you can say ionic radius. अभी ये थोड़ा सा अलग ट्रेंड है. Ionic radius का ट्रेंड थोड़ा सा अलग होता है. आयन कैसे तैयार होता है ये पहले देखते हैं हम लोग. अब देखिएगा यहाँ पे लिखता हूं मैं. देखिए, suppose M is the element or M is the element, this loses electron, so here will be M plus and one electron is lost. Another case, M is the element whose gains electron. Okay, M is the element who gains the electron and it forms M minus. अभी दोनों में फर्क देखिए. First case is nothing but the cation and second case is nothing but the anion. So the trend is different. This is cation and this is anion. Means Here is M is the element. M is a general element. It's not magnesium and all. It is a general representation for the element what I have taken. I have considered. M is the element. This M is the element which loses electron, and that's why one electron is lost. The positive charge increase, that is called a cation. So in first case, cation is formed, or in second case, this element gains the electron and negative charge is developed. That is, you can say anion. So here anion is formed. So here is the cation, here is the anion. That is what we get here. So cation and anion. And this phenomenon is called as ionization. This phenomenon is called as ionization. So that is also called as ionic radius. Okay, that is called as also ionic radius. So instead of atomic radius, you can make it more ionic radius. Radius of the ion, because atomic radius will decide the size of an atom. But when we talk about the ionic radius, more correct heading will be this ionic radius. Ionic radius kya hota hai? See, this is the M element, which is a natural norm. But whenever this element either loses electron, either gains electron, it gets converted into cations or anions. Then what happens? Then what happens about the ionic radius? So अब देखिए periodic table में बात करते हैं तो already हमने देखा कि these are the metals and this metal has the tendency to lose electron. This metal has the tendency to lose electron and this non-metal has the tendency to gain electron. तो हमने कभी भी देखा है कि sodium prefer to lose electron. So reaction generally ऐसा होता है कि sodium has lost electron to form Na plus one electron is lost and chlorine has gained electron to form Cl minus. तो generally जो non-metals होते हैं ना, non-metals इस area में आपको मिलते हैं. So these non-metals has the tendency to accept electron to form Cl minus, like Cl minus, sulfur minus, है ना, fluorine minus, chromium minus, ये सारे element देखते हैं. Sodium, magnesium, lithium, potassium has the tendency to lose electron to form cations. उसके पीछे भी reason ही है, no doubt at all. These are the elements जो left side में element है, they prefer to lose electron. And जो right side में element मिलते हैं, they prefer to gain electron and they form cations and anions. हाँ देखिए ये दो examples हमारे सामने already clear है. एक से हम लोग chlorine में convert करते हैं. This is nothing but the sodium. Okay. Suppose sodium is the element. Sodium is the element which has atomic number 11. So it has plus 11 protons and it has 11 electrons. It has 11 electrons. Suppose sodium has a tendency to lose electron. Sodium एक electron lose करता है, so it will become now 10 electrons होंगे. So what happens? This is the nuclear charge which is plus 11. जब सोडियम एटम होता है तो उसे 11 इलेक्ट्रॉन अट्रैक्ट करने हैं और जब ये सोडियम एक इलेक्ट्रॉन छोड़ देता है तो उसे 10 इलेक्ट्रॉन ही अट्रैक्ट करने हैं. अब देखिए न्यूक्लियर चार्ज नहीं बदलने वाला. न्यूक्लियर चार्ज इज प्लस 11. सो द सेम न्यूक्लियर चार्ज plus 11 attracts the 11 electron and same nuclear charge attracts the 10 electrons. So what will happen? 100% surely क्या होगा कि plus 11 को plus मतलब minus 11 इलेक्ट्रॉन को अट्रैक्ट करना थोड़ा सा डिफिकल्ट होगा और plus 11 को 10 इलेक्ट्रॉन अट्रैक्ट करना थोड़ा सा इजियर होगा. तो इलेक्ट्रॉन का नंबर कम होता जाएगा तो उसे अट्रैक्ट करना थोड़ा सा इजियर होगा. तो जनरली सोडियम लाइक मेटल व्हेन लूजेस द इलेक्ट्रॉन द साइज डिक्रीज होता है. साइज क्या होता है? डिक्रीज होता है बिकॉज इलेक्ट्रॉन लूज करेंगे तो साइज थोड़ा सा कॉन्ट्रैक्ट होगा बिकॉज प्लस 11 चार्ज हैज टू अट्रैक्ट दिस ओनली 10 इलेक्ट्रॉन्स एंड दैट्स व्हाई साइज विल डिक्रीज. सो दैट हैपेंस हियर. So generally metal when loses the electron their size decreases. साइज क्या होता है? उनका डिक्रीज होता है. और when नॉन मेटल की बात करते हैं, क्लोरीन की बात करते हैं हम लोग, क्लोरीन के अंदर यहाँ पे देखिए क्लोरीन में क्लोरीन का चार्ज है +17. तो इट हैज +17 चार्ज एंड -17 इलेक्ट्रॉन्स. अगर क्लोरीन एक इलेक्ट्रॉन ले लेता है, इस केस के हिसाब से क्लोरीन इलेक्ट्रॉन ले लेता है तो इट बिकम्स -18 इलेक्ट्रॉन्स. तो पहले 17 प्रोटॉन्स को 17 इलेक्ट्रॉन कैच करने थे, अभी 17 प्रोटॉन को 18 इलेक्ट्रॉन कैच करना है. तो व्हिच इज इजियर फॉर दैट? +17 को -17 को अट्रैक्ट करना, मतलब 17 प्रोटॉन को 17 इलेक्ट्रॉन को अट्रैक्ट करना अलग बात है और 17 को 18 इलेक्ट्रॉन को अट्रैक्ट करना बात है. यहाँ पे इलेक्ट्रॉन बढ़ रहा है, न्यूक्लियर चार्ज उतना ही है. तो इंक्रीज न्यूक्लियर चार्ज ये एक इलेक्ट्रॉन पे ज्यादा एक्सपांड होता है तो उसकी पावर कम होगी. मतलब आपके पास 100 रुपए है और 100 रुपए आपको 10 लोगों में बांटने हैं और 100 रुपए आपको 9 लोगों में बांटने हैं. 100 रुपए अगर हम 10 लोगों में बांटेंगे सबको 10-10 रुपए मिलेंगे. 100 रुपए अगर हम 9 लोगों में बांटेंगे तो शायद सबको 11-11 रुपए मिलेंगे. तो बढ़ जाएंगे. तो इसका मतलब क्या होता है कि जब इलेक्ट्रॉन बढ़ेंगे तो न्यूक्लियर चार्ज स्प्लिट होता है एंड दैट्स व्हाई साइज थोड़ा सा क्या होगा? इंक्रीज होगा. तो इन केस ऑफ नॉन मेटल जब इलेक्ट्रॉन गेन करते हैं तो साइज इंक्रीज होता है. तो एनायन के केस में साइज इंक्रीज होता है, कैटायन के केस में साइज डिक्रीज होता है. That is the trend what we get for the properties of this ionic radius of the ion. So whenever any metal forms a cation or anions, so when cation is formed, size generally decreases, or whenever anion is formed, size generally increases. This is the trend what occurs here in this periodic table. So while moving from left to right, यहाँ पे क्या होता है कि इलेक्ट्रॉन छोड़ने की टेंडेंसी कम कम होती जाती है और यहाँ पे इलेक्ट्रॉन लेने की टेंडेंसी बढ़ती जाती है. That's why atomic रेडियस इंक्रीज होता जाता है. एटॉमिक रेडियस इंक्रीज होता जाता है और इस तरफ एटॉमिक रेडियस कम होता जाता है. टॉप टू बॉटम की अगर बात करते हैं, टॉप टू बॉटम में शेल्स ज्यादा है, एटॉमिक साइज ऑलरेडी बड़ी है, तो इलेक्ट्रॉन छोड़ने की टेंडेंसी बढ़ के इलेक्ट्रॉन लेने की टेंडेंसी कम होती है, और इलेक्ट्रॉन छोड़ने की टेंडेंसी अगर बढ़ेगी तो साइज क्या होता है, डिक्रीज होता है. तो कैटाइन साइज मतलब आयनिक रेडियस डिक्रीज होता है. ट्रेन देखेंगे तो डिक्रीज होता है. या हाइड्रोजन के कंपैरिजन में पोटेशियम का साइज ऑलरेडी बड़ा है, बट हम पोटेशियम के साइज के साथ पोटेशियम प्लस आयन का साइज अगर हम कंपेयर करते हैं तो दैट विल बी अ स्मॉलर वन. तो टॉप टू बॉटम आयनिक रेडियस जो होता है उस हिसाब से डिक्रीज होता है, और लेफ्ट टू राइट आयनिक रेडियस जो है वो बढ़ता जाता है. दिस इज द ट्रेंड व्हाट वी गेट हियर फॉर द आयनिक रेडियस फॉर द आयंस. होप यू आर गेटिंग दिस. व्हाट इज द आयनिक रेडियस? तो आयंस क्या होते हैं पहले मैंने बताया. Any of the metal whenever loses electron from the cation, or whenever any of the metals gain the electron forms anions. Here in this periodic table, left side has the metal and right side has the non-metal. So metal has a tendency to lose electron, और इलेक्ट्रॉन लूज करेंगे तो साइज क्या होगा, कम होगा, और यहाँ दे हैव द टेंडेंसी टू गेन द इलेक्ट्रॉन, तो साइज क्या होगा, बढ़ेगा. सो हम जब लेफ्ट टू राइट मूव करते हैं, तो आयनिक रेडियस क्या होता है, इंक्रीज होता है, और टॉप टू बॉटम करेंगे तो क्या होता है, वो डिक्रीज होता है, because tendency to lose the electron increases and tendency to attract the electron decrease होता है. So that's why इस तरीके का ट्रेंड हमको आयनिक रेडियस के अंदर मिलता है. Are you clear with this? So there are the two properties what we have discussed here. Number one is nothing but you can say trends in atomic size, and number two is nothing but the trends in ionic radius. Clear with this? So remaining trends we'll discuss tomorrow. But the fundamental thing has to be remembered. Number one, what is effective nuclear charge, and number two is nothing but you can see here screening effect or shielding effect. On that basis, we can understand this trend. Clear with this? So, see you tomorrow. Thank you very much.